Hey guys, welcome to Deep Dive Coding. Today we solve LeetCode problem of the day. So this is tagged easy problem, but this problem is asked in so many companies including Yahoo. Can you solve this optimally? Let's check it. So in this video I will go through this way. First I will explain the questions, then go to the simplest brute force approach, and third one is I will give you the 3 optimized bit manipulations technique. But this is not the exhaustive list, so you can find your own way. So this is asked in the Yahoo. So let's start the video. The question is basically given a integer number. This is always integer, that means that is given in the question, then n will go up to 10 to the power 31 minus 1. So it is under the integer limit, and you have to say whether it is a consecutive bit is alternative or not. That means if you try to check this one, this is alternative 1 0 1, this is alternative. Let's say 1 0 1 0 1 0, these are alternative, but if it this way, this is not alternative. So we have to say that whether the given numbers bit has alternative or not. So if you consider the 32-bit integers, let's say there are so many zeros in front and 1 0 1, and this is alternative because we just ignore this much part. We have to consider up to this part only. Now if you look into the 7 binary representations, it will give you 1 1 1. Is it alternative? No, it's not, so it is false. Now come into the 11 binary representations, it will be 1 0 1 1. This is also not alternatives. So the basic, like, you can think about a simplest approach. Let's say there are so many zeros in front of numbers that can happen. We have to consider up to this much number. What is means this much numbers? That means we have to track up to the most significant bit that is set. We have to consider from here to till the end. This much portions we have to consider for alternative or not. So there are two steps can be done. First, we have to find the most set significant bit. That means where is the one in the leftmost positions. So if you find this, this is the most significant bit which is set, and we just iterate from right to left. That means we start over here. Let's say this example, we start first pointing over here, and we just try to go to the up to the most significant set bits, and just check whether it is same as previous. If it is same as previous, then we just return the false, because it have to be the different than the previous. If you look into the coding part, it is fairly simple. First, let's bit positions, that is initial positions as 0, then most significant bit positions, that is 0 initially, we have to update in our answer. We traverse through up until the 32-bit integer. So we just put in right shift operator of bit positions. That means let's take an example, that 1 0 1 0 1 1, and we want to shift this up to 2 positions to the right. That means this one go, sorry, 1 position, this one go over here, this will go over here, this will go over here, and this will go over here, and this will go over here. Then what is the number actually? That means it will go use 0 first. It will, as it is placed to the these positions, so these positions will filled by 0. So it will be like 0 1, this one is this one, 0 1 0 1 and 1. This is the one bit to the shifted to the right. This way we just bit position shifted and ampersand with 1. Why? Because we want to know, let's say we want to know this bit, so we just this bit position to the this one, this position, so we have to shift the 3 positions to the right. And when we shifted 3 positions to the right, that means it will give you 1 0 1. This will give you the number, and when we ampersand with 1, that means we are just and with 1, and it will give you either 1 if it is 1, otherwise it will give you 0 if it is 0. So in that way we just check whether that bit is set or not. That means if it is set, we just update our most significant set bit positions to the bit positions. This is fairly simple, and in each iterations we just bit positions plus plus. Now you can avoid this much manually. You can use bit set of 32 positions and pass that with the numbers of n, so that you get the binary representations of n into the 32 bits array size. And when you try to count, let's count, you have one built-in function in C++, count L, that you, when you pass this with the n, it will give you the leading 0, and when you subtract 32 minus not 32 31 minus leading 0, then it will give you the most significant set bit positions, that you can also use that. Here I will show the C++ explanations, but Java and Python code you can find in the descriptions. Those are the exactly similar structure. So now come into the second part. Now once you have the most significant bit positions updated, now bit position to the 1, because we just track the last bit as the first bit 1. That means let's consider 0 1 0 1 1. This is an example, and we just positions our pointer over here, and we just check these positions from 1 positions from right. And if the last bit not equal to that positions bit, that means we are in the good situations, then we just update our last bit to the opposite one. And in this way, if it is not, then it will be similar like consecutive same bits, that we just return the answer was false. In each iterations we just increase our bit position, and at last if these else conditions never executed, that means it is true. What it means? That means the number is actually in the alternative way. Now come into the optimized versions. I will give you the 3 optimized. This is the second solutions. You consider this is the first brute force and this is the second. So now let's try play with the bit manipulation part. Let's take an example n given over here, and we just right shift to the 1 bit. That means it will be 0 0, it will be 0, then 1 0 1 0, and finally 1. Now if you do this AND operations, that means it will give you 0 over here, 0 0 0 0 0 0 and 0. So now it's all are 0. That means these are the consecutive. That means you can consider this way, 0 1 0 1, and if you write 2 are shifted 1 positions ahead, then it will give you the 1 0 1. So when we AND operations, it will always give you the 0. This is one case, but it will fail in this case. If you try to look, if you only place this is as the valid conditions, it will not given like 0 1 0 0. If you try to do the same things, and we have shifted 1 positions ahead to the right directions, this will give you 0 0 1 0, and try to take the AND, so it will give you all 0, but this is not the valid answer. So you have to check another things also. Now come into the another conditions. So n is given over here, and we just shifted to the 2 positions ahead. That means 0 0 0 0, and this one will go over here and 1 0. Now you take the AND, it will give you 0 0 0 0 0 0. Okay, and if it is now again you shifted the n positions towards the two directions, that means is it same as this? No, it is not same. That means it is not possible. Now try to run for the valid answers. Let's take these conditions over here. So first we need to shift it to the two directions to the right. That means 1 0 0 0. This is the things, and take a AND operations. So it will give you 0 0 1 0, and you have to, this is the n, so you have to shift it towards the right direction 2 positions. It will 0 0 1 0. Is these two numbers same? Yes, it is same. So this condition is also true. So in this way, if this is the main conditions, complete conditions, n ampersand n shifted to the right 1 equal to 0, and n ampersand n shifted to the right directions 2, right shift 2 equal to right shift of n, then it's actually true. That means you can consider if these things happens, then it is true, else false. This is one optimization approach. So please like and subscribe the channel. If you guys found anything helpful, please comment that you understood, or which part you do not understood. Please comment in the comment box. Use that comment box to inform me. And come into the third solutions. This is also interesting. N is given over here, and you just right shift 1 positions and take the plus. How you can do that? Right shift 1 positions, that means 0 0 0 1 0 1 0 1. Now it is right shifted. Now take the additions, so it will give you 1 1 over here, 1 over here also, 1 1 and 1. Now it will be 0 0. Let's assign to the m. This is the m. Now m is given over here 0 0 1. There are 1 2 3 4 5 6 1 3 4 5 6. Now take m plus 1. That means when you try to add over here 1, it will be 1 0 0 0 0 0 and 0. Okay, now you take the AND operations of these two numbers, so it will give you 0 0 0 0 0 0 0 and 0. So all are 0. If it is all are 0, that means it is a valid conditions. So first of all we have to take m, that is right shift of n plus n, and if m and m plus 1 is 0, that means it's a valid condition, then you can return is true, otherwise it is false, else false. Now come into the fourth solutions. This is another bit manipulation technique using XOR operations. How you can do that? First of all we have to right shift one positions, that means 0 0 0 1 0 1. This is right shifted to one positions. Now take the XOR operations. XOR operations we will do the same simple things, like if it is same, that means 0 XOR 0, it will give you 0, and 1 XOR 1, it will give you 0, and if you take 0 XOR 1, it will give you 1, and 1 XOR 0, it will give you 1. That means if it is different, then it will give you 1. If it is same, it will give you 0. Now do the same things. So it will be 0 0 same, 0 0. Now 1 0 is different, it will give you 1 1 1 and 1. Now you have the m, and use the same as the previous techniques, like once we have all the ones over here, all the ones, we just take plus 1 and %, like AND operations. So this is the m, 0 0 1 1 1 1, and take the plus 1, that means it will give you plus 1 over here, so it will give you 0 1 0 0 0 and 0, and when you take the AND operations, it will give you 0 all 0. So this is also a valid condition, that means you can return, if it is true, then you can return true, otherwise false, else false. Now do not forget to subscribe the channel if you guys is helpful. Thank you guys, thank you for watching, stay tuned for more videos.